Hello guys and welcome to a new episode. Today I will again take a trip to the scrapyard. This time I'm looking for tools that I deem to be too good for the trash. And I want you to follow me along and have a little walk around here, see what we can find here today. Now what do we have here? A huge gear motor, and I'm always looking for those. And this one is heavy, I guess probably 80 kilograms or more. You can tell by the size of the dumbbell next to it. Unfortunately, this one has been here a little too long and it's too damaged and rusty. And this looks like a huge heat exchanger. And for some reason, the first association with this is that I look at it and think, did they rip this out of a nuclear power plant? There are marks on here saying DDR, and that's maybe for German Democratic Republic, as in East Germany 1976. I'm sure it's completely safe. Nothing to see here. And another Dalex TIG welder, and according to the nameplate, also for AC TIG welding, in other words, suited for aluminium welding. But unfortunately, behind a fence, probably someone else has already shown interest in this one. Too bad. And what is this? A super heavy machine. The style of the motors tells me that this might be more than 60 years old, maybe even World War II or earlier. From what I can tell, this is some kind of steel bending machine or press. Certainly much too good for the trash, but I don't have the space for something like this. And what do we have here? A wood lathe. This has only been here for a few days, or it would be much rustier, and I would have seen it before. So if I can get this for a few bucks, this is a total keeper. Now here's a little vise that I found at the scrapyard as well. It was made from cast iron, and judging by the form of the casts, I'd say it's pretty old. The yellow paint looks quite playful, but I'm certain that it's not the original paint. I personally like the look of raw cast iron, and that is why I will use this opportunity to test a chemical paint stripper that I have never used before in any of my videos. But first I have to take the vise apart. I remove the jaws and inspect the ways. Some parts have broken off and I might later try to weld the cast, but at this point in time I don't have the right equipment at hand for that. I also take out the handle, which has some surface rust. I apply a layer of the paint remover, and after just half an hour or so, the yellow layer is brittle and has crumbled all over the vise, and I can remove it pretty easily with a wire brush. Under here we find another layer of gray paint that I would suspect to be the original one. We also find the letters DRGM. On old German vises or other tools you can sometimes find the letters DRP or DRGM. What do they mean? Are those company names? Well, DRP is short for Deutsches Reichspatent, which literally translates to German Empire Patent or Patent of the German Empire. But what about DRGM then? Well, that's short for Deutsches Reich Gebrauchsmuster, which means German Empire Utility Model. Now, I'm no legal expert, but a utility model is described as the little brother of a patent or some form of a minor patent. And the letters DRGM and DRP were used from some point in the late 19th century until around 1945. So the vise must be at least that old. To get all the paint off, I had to apply the paint remover 2 times though, and make sure to spread it over all the surfaces. In the end, I used a bucket and a brush to remove the remainder of the paint. Much less stressful than physical means of paint removal. But on the downside, this time you're left with a mixture of potentially toxic old paint and the nasty paint stripper. And in the end, I had to revert to a wire brush, abrasive fabric, and WD-40 once again to really get rid of all the paint. The little vise gets some new grease and is slightly oiled all over, and there you go. Not a big one, but surely a beauty. Let's take a closer look at this wood lathe then, and according to this old sticker, it was made, or at least sold by, a German company by the name of Rotwerk. Holzdrechselbank means wood turner's lathe, and it ran on 230 volt single phase AC. Leerlaufdrehzahl means rotational speed under no load, and it's rated at 2510 minute to the -1 or revolutions per minute. Spitzenweite is the maximum distance between centers, or the maximum length of the workpiece, in other words, which is 1000 millimeters or 1 meter. And Spitzenhöhe literally means height of center, and that's 17.8 centimeters. Under that, it states the maximum diameter of the workpiece, but that number is no longer readable. It has an old on-off switch that is no longer connected to anything, 2 screws for connecting protective earth wires, of which one is missing, and another sticker stating the correct rotational direction. And that direction is important. Among other reasons, this is important because this part here would turn itself loose if the spindle were to rotate the wrong way around. There is superficial rust on the bed, tool rest, tailstock, and on the spindle. And as we have seen before, no motor is installed inside anymore. So let's look for a new one in my shelves then. This one might do the job. It seems to be around the right size and already comes with a pulley that could match the ones installed on the lathe already. So I start by cleaning the machine bed that simply consists of steel tubes. A better machine would have a bed made from cast iron. And I remove the rust from the spindle with a piece of abrasive fabric. And I take off this cover here in order to attempt to clean the bearings and apply some new grease. It's doubtful that this is a very effective method of doing that, but I'm not going to take this apart any further, because I'm sure that I would do more harm than help and never quite get it back together. And I'm installing the motor inside the enclosure. Not only does it fit inside, it also can be installed using the original mounting holes without any need for modifications. Even the belt I ordered fit right away. But we have a big problem here. The motor turns in the wrong direction. Now can't you just let the motor turn in the other direction then? Well, in this case, unfortunately, not. There are many types of motors that can rotate in both directions and deliver the same kind of power. A 3-phase induction motor, like we saw in the last video, can just be reversed by swapping 2 phases, or if run on single phase AC, by swapping the capacitor connections. But this is an induction motor that was specifically built to run in just one direction, and it was sold as a right-turning motor. When measuring the resistances of its connections, you can clearly see that the winding for the mains and the auxiliary winding for the capacitor are not symmetrical and interchangeable to run the motor in another direction. Just turning the entire lathe around so that the tailstock would be on the left-hand side of the operator is also not an option, because there are parts here that would loosen themselves during operation if the lathe would turn in that direction. So I came up with another plan. Install the motor the other way around. But unfortunately, the old pulley cannot just be moved inside the housing like this. It has a much smaller inner diameter than the width of the spindle here in the middle inside the enclosure. So I have decided to go for a much more complicated solution that has another big advantage though: installing the motor out here, while at the same time building a new frame that will greatly increase the stability of this lathe that was made from very light and cheap materials like bent steel sheets. So I took 2 steel tubes that I want to install under the lathe, making the entire structure more rigid. A bunch of holes are drilled into the tubes as well as into the old frame of the lathe. Note that I'm using the Metabo drill I repaired in the last video, already being useful here in the shop. Then a bunch of threaded stainless steel rods are cut to length and inserted into these tubes. Temporarily held in place by a bit of tape, they are tacked to the steel with a TIG welder just so that they will hold inside the tubes on their own, and then they are TIG welded to the bottom side of the tubes. This is where then steel nuts will be fastened that will hold the sheets that comprise the old frame of the lathe in place. Some excess material is cut off from these tubes with an angle grinder and then welded between the two tubes at both ends to further improve stability. From this point on, I was using MIG-MAG welding instead of TIG for this entire project, and I'm still not really used to it and did not have a lot of training in MIG. But considering that fact and the fact that I'm using an over 50-year-old machine that I turned from a hunk of scrap into a working machine, I think these welds look pretty decent. The videos showing how I repaired that welder can be found in the video description, by the way. To build a new motor housing that can hold the new motor or potentially other motors that are better suited for motor speed adjustment, I use steel plates that I also salvaged from the scrapyard. After removing the paint from one side, I used a pen to mark the outlines of two new parts, and I cut them out with a cutoff wheel. They will be the side walls of the motor housing. Holes are drilled through the plate using the drill press, and an ordinary old-fashioned file is used to remove the spaces between two adjacent holes. This will be needed to apply tension to the belt connecting the pulleys. But there is still paint on the back side, and since it has such an uneven surface, I try my luck with a chemical paint remover instead of purely physical means of paint removal. After a few hours, I can somewhat easily remove the top paint layers with a wire brush and a rag. Now this method works very well, but it leaves you with a nasty cocktail of chemicals that need to be disposed of properly, of course. And after finishing the tedious job of hand filing the holes to the shapes and sizes I really require here, the two side walls are connected with two angle pieces that I already prepared in the meantime. The parts are thoroughly welded together, among other things with the help of an adjustable magnetic angle. And now, for the first time, I was actually able to install the motor with its correct orientation. And the initial idea with this new motor housing was actually that I wanted to be able to slide it a few centimeters to the left and right and then adjust it again so that the motor could be connected to any of the old pulleys for speed adjustment. But because of time restraints, I decided to just weld it in place, at least for now. Next, the housing will have to be closed with steel sheets. And a project like this one is perfect for me to get more into MIG-MAG welding, since I never used this welder before to weld thin steel sheets, for example, while I did almost everything with TIG for the past 5 years or so. There are still some finishing touches missing, like paint and vent holes, but I'm also kind of under pressure here to get this video out. So I'm going over to removing the rust from the remaining parts, namely the tool rest and the tailstock. And I guess it's time for a test now. Now, I'm no wood turner, and this is the first time I'm ever attempting this. But in my opinion, this machine works pretty well for something that I just picked up from the scrapyard a few days ago. So guys, if you liked this video, give it a thumbs up to let me know that you want to see more of it. And support this channel, visit patreon.com/tpai.